Hello, I'm gonna retry this video since apparently my last one was really glitchy. So just make sure you're on page 9 of your ready book so that way we can get started. And if you need a second, just pause this video till you get to page 9 and unpause when you're there. Alright, now that you are to page 9, so we're going to do a quick review. So remember that the rigid transformations, that there are 3 types. There's a translation where you slide a figure from one place to another. There's a reflection where you flip a figure over a line, and a rotation which turns it. It's like the example we used here. So if you have my little giraffe, translation, it's just moving, not changing its shape or its size. Reflection, you flip it, so it's being flipped. And a rotation turns it, so this would be a rotation. And you can see those in the example here of our translation, rotation, and reflection and rotation. So when we get to the first problem, so we have this figure here, A, B, C, D, E, F, and we need to figure out, is this new image a reflection, a translation, or a rotation? So we can see that it is a reflection because it is being reflected across this line of reflection. So go ahead and draw your arrow right here to show how it's being moved, and then draw your line of reflection down here because it's being flipped. If you haven't finished writing this stuff down, just go ahead and pause the video until you get it done. Alright, now that you are back, so the next thing we need to talk about is how do you identify the line of reflection? So the line of reflection must be the same distance from each part of the original figure as from the corresponding part of the image. So it's the same distance. So for example, B is only 1 unit away from our line of reflection. Q is also 1 unit away, so they are the same distance from our line of reflection. A is 8 units away from our line of reflection, and P is also 8 units away, which means that we know that those are corresponding parts. So again, now identify the line of reflection by saying it must be the same distance from each part of the original figure as the corresponding part of the image. Alright, so next part. So when figures are the same shape, you can identify corresponding parts between the figures. Angles in the same relative position are corresponding angles, so they have the same measure. Sides in the same relative position are called corresponding sides. They have the same measure. So like that figure we just had, AB is equal to PQ. So again, this AB is equal to PQ. So the long is equal to the long. EF is equal to TU. CD is equal to RS. FA is equal to UP. BC is equal to QR. And DE is equal to ST. So how do the lengths of the corresponding sides compare? So we know that the lengths are the same. So like we talked about, the long length of AB that was 7 units long is equal to the long length of PQ, which is also 7 units long. And we can compare that with the grid by counting the number of boxes. When something is parallel, you can write that by doing these two lines that look like this. So it's like instead of an equal sign, you flip it like this or rotate it so it's like this. So that shows that something is parallel. So line AB, remember that's our long line, is parallel to line FE. So they are parallel, which means they'll never touch. And they are always the same distance apart. So that's how we know they are parallel, because they're always that same distance away from each other. So the other part is that the corresponding pairs of sides are also parallel. So what do we notice about the corresponding pairs of sides in the figure? That the corresponding pairs of sides are also parallel. So the original figure had parallel sides, and the new figure also had parallel sides. Again, if you're not done writing this down in blue, then just make sure that you pause this video until you're done and then hit play when you are ready. Alright, now that you're back, now we are at the top of page 14. So we have this image here in blue, and it's made these 3 images in pink. So we have to figure out which all of these are individually. So this figure here is a rotation of the original figure. So we can see the center of rotation point right here. So this is rotated. This figure is a translation because it's just slid over. And then this picture is a reflection because it is flipped. So if we have angle V here is our acute angle, so the smallest angle, and it is the equivalent to angle P. So these are the same angle measures, and we know this because angle V, when it is reflected, it would be right here. Angle Y is the same as angle S, angle Z is the same as angle T, angle X is the same as angle R, and angle W is the same as angle Q. And we know this again because angle W is this obtuse angle. Angle Q is also obtuse. And if we were to reflect it, this angle W would land exactly where angle Q is. So again, corresponding angles means that they are the same angle measurements. So for B, we have again, the measures are the same. We can say that we use the grid to identify all the right angles in each figure. And we see that angle V and angle P are both 45 degrees. They're both our acute angle. Angle W and angle Q are both 225 degrees. They are both our obtuse angle. We could use a protractor to measure the angles, but for now we're just going to say that we know that this is both 45 and these are both 225. Again, if you need a second to write this all down, just pause the video. Alright, now that you're back, we're going to finish off with the last couple problems. So again, we have this connect. So we are on page 10. I messed up the page number earlier. So how can corresponding parts help you determine that an original figure and its image are the same size and shape? So you can verify that the figures have the same corresponding side lengths so that they have the same number. So if something is 4 lengths wrong over here and 4 over here, then you know that they're corresponding because they have the same length and the same angle measure. So if you have a 90 degree here and then you flip it and you have a 90 degree here, so in other words you reflect it, then you see that they have the same angle measure. And you can check to see if, say, the parallel lines here are also parallel over here. So those are the ways that you determine that has the same shape and the same size, that has the same angle measures, it has the same side lengths, and that the parallel lines stay parallel. For this image, so transform this figure right here into another figure. So you can either reflect it, like the example shows here, you can rotate it, or you can translate it, which again just means to move it or slide it over. And then we talk about the corresponding parts. So how JK, our longest part, is equal to AB. So we know that they're corresponding because we have 4 and 4. Corresponding angles, so angle N here is corresponding to angle E, so they both have the same measure. See, N is our obtuse angle, E here is our obtuse angle. So you can draw any example. This is just one that you can use. You could also use translation or rotation or reflection. Again, just pause this video if you're not done. This was the last slide that I had for you, and then just make sure that you do pages 11 and 12 in your Ready workbook. And if you do not have a Ready workbook yet, just make sure that you look at the PDF of pages 11 and 12 that is on Google Classroom. Write your answer on a scrap piece of paper and upload that way. So you just take a picture of your work and upload it. So again, if you need anything else, just pause the video at whatever you need it. If you have questions, you can email me. Other than that, that is all that I have for you. Have a good day, and I hope that this video is a lot less glitchy than the the other ones.